The Sukhoi Su-30MKI is a twin-jet multi-role fighter aircraft developed by Russia's Sukhoi and built under license by India's Hindustan Aeronautics Limited, HAL. The Su-30MKI is actually a variant of the Su-30, which itself is a derivative of the Su-27, a Soviet-era air superiority fighter. India has been operating the Su-30MKI since 2002 and has been upgrading the aircraft in phases to keep it relevant and, well, effective in the face of evolving threats. The Indian Air Force, or IAF, has been upgrading the Su-30MKI in several phases, with the current upgrade program being the most comprehensive so far. The upgrade program, which is being carried out by HAL, aims to enhance the aircraft's avionics, radar, and combat capabilities. Some of the key upgrades include, first, the radar upgrade. The Su-30MKI is being equipped with the N011 MBARS radar, which is a phased array radar system that provides improved range and resolution. The radar upgrade includes the AESA radar system, a new antenna, and a more powerful transmitter, which enables the radar to detect and track multiple targets at longer ranges. The indigenously developed Rudram-II radar with gallium nitride technology provides superior detection range tracking and resistance to electronic jamming. Second, the avionics upgrade. The aircraft's avionics are being upgraded with new computers, displays, and communication systems. The upgrade includes the integration of a new helmet-mounted sight, which provides the pilot with improved situational awareness and targeting capabilities. So, let's talk about the mission computer upgrade. The mission computer is being upgraded to improve the aircraft's combat capabilities. The new computer actually enables the aircraft to engage multiple targets simultaneously and, provides improved data processing and storage capabilities. Moving on, the Su-30MKI is being equipped with an advanced electronic warfare suite, which includes a new radar warning receiver and a jamming system. This EW suite enables the aircraft to detect and counter enemy radar and communication systems. Now, about the integration of new missiles. The Su-30MKI is being integrated with new missiles, including the BrahMos air-launched cruise missile and the Russian-made R-77 and R-73 missiles. The integration of these new missiles really enhances the aircraft's air-to-air and air-to-ground capabilities. Also, the aircraft's engines are being upgraded to improve their performance and reliability. The upgraded engines provide improved thrust and fuel efficiency, which enables the aircraft to stay in the air for longer periods. And finally, the Su-30MKI's airframe is being strengthened to extend its service life. The airframe upgrade includes the replacement of certain components and the application of new coatings to protect the aircraft from corrosion. The Indian Air Force has plans to upgrade the Su-30MKI further in the future. Some of the proposed upgrades include: the Su-30MKI is actually being considered for an upgrade to 5th generation avionics, which would include advanced sensors, communication systems, and data links. This upgrade would enable the aircraft to operate in a network-centric environment and provide much improved situational awareness. Additionally, the Indian Air Force is looking at integrating an advanced radar system, like the Active Electronically Scanned Array radar, which would offer better range and resolution. The Indian Air Force is also considering replacing the Su-30MKI's engines with more advanced and efficient options, such as the Saturn AL41F1S or even the indigenously developed Kaveri engine. On top of that, there's talk about applying stealth coatings and making design modifications to reduce the Su-30MKI's radar cross-section, which would improve its survivability in modern combat scenarios. The upgrade program for the Su-30MKI has faced several challenges, including delays. These delays have occurred due to various reasons like technical issues and funding constraints. Also, the cost of the upgrade program has exceeded initial estimates, which has put a strain on the Indian Air Force's budget. Technical issues have also cropped up, especially with the integration of new systems and components, and these have required significant debugging and testing. Supply chain issues have played a part too, with delays in the delivery of critical components and systems affecting the overall timeline. The upgrade of the Su-30MKI is a critical program for the Indian Air Force, as it enables the aircraft to remain relevant and effective in the face of evolving threats. Although the upgrade program has faced several challenges, The Indian Air Force is, without a doubt, committed to completing the program and ensuring that the Su-30MKI remains a key component of its fighter fleet. Looking ahead, the future upgrades proposed for the Su-30MKI, including the integration of fifth-generation avionics and advanced radar systems, will further enhance the aircraft's capabilities and make sure it remains a formidable platform for the Air Force. The current specifications of the Su-30MKI are, well, pretty impressive. It has a length of 21.9 meters, a wingspan of 14.7 meters, and a height of 6.4 meters. Its empty weight is 18,400 kilograms, with a maximum takeoff weight of 34,000 kilograms. The engines consist of two Lulka AL31 FP turbofan engines, each having a thrust of 12,500 kilograms. The Su-30MKI has a maximum speed of Mach 2.0, which is 2,400 kilometers per hour, or about 1,500 miles per hour, and a range of 3,000 kilometers. Its service ceiling is 17,000 meters, and it has an armament capability of one 30mm GSH-31 cannon, 6 R-27R1 missiles, 6 R-73E missiles, 4 R-77 missiles, and 1 BrahMos missile. Pakistan's reaction to the Indian upgrade of the Sukhoi Su-30MKI fighter jet would likely be one of concern and caution. The Su-30MKI's capabilities, particularly with the integration of the BrahMos-ER missile, pose a significant threat to Pakistan's air defense systems. Pakistan might respond by enhancing air defense systems, upgrading their air defense systems, including the Chinese-origin HQ-9BE surface-to-air missile systems and JY-27A radar networks, improving fighter jet capabilities, modernizing their fighter jet fleet potentially with the induction of new aircraft like the J-35, developing countermeasures, working on countermeasures to neutralize the BrahMos-ER missile's effectiveness, such as developing advanced electronic warfare capabilities, strengthening diplomatic efforts, engaging in diplomatic efforts to address concerns and potentially seeking support from allies like China. It's essential to note that the Indian upgrade of the Su-30MKI is part of a broader effort to enhance its military capabilities, and Pakistan's response will likely be shaped by its own strategic priorities and security concerns. On the other hand, the Pakistani J-10C fighter jet is a highly capable aircraft that can indeed compete with and rival the upgraded Indian Su-30MKI fighter jet. One key advantage of the J-10C is its AESA Radar, which is more difficult to jam and provides better electronic warfare capabilities compared to the Su-30MKI's PISA radar. The J-10C also boasts the PL-15 long-range air-to-air missile, which outperforms the Su-30MKI's Russian R-77 and French MICA missiles in terms of range and guidance capabilities. Additionally, the J-10C has a higher thrust-to-weight ratio due to its lighter airframe and more advanced engine, making it more maneuverable than the Su-30MKI. However, the Su-30MKI has its own strengths, including its endurance and ability to carry more ordnance over longer distances. Its twin-seat design also provides an advantage in terms of situational awareness and combat flexibility. Recent air battles have demonstrated the J-10C's capabilities, with Pakistan claiming to have shot down several Indian aircraft, including Rafales and a Su-30MKI, using the J-10C and its PL-15 missiles. While the exact details of these engagements are disputed, they suggest that the J-10C is a formidable opponent in air-to-air combat. Overall, the J-10C and Su-30MKI are both highly capable fighter jets with their own strengths and weaknesses. The outcome of any potential engagement between them would depend on a variety of factors, including the skills of the pilots, the specific configurations of the aircraft, and the tactical situation.